Okay, so let me, I think you have mailed to me this project. Okay, just wait 1 minute. And in last, I will show you what is the things. Yeah, I will show you the DBR. That is called the design based report. So, how was your yesterday sessions? I think there is some people who are not present yesterday, but don't worry. It's just an so the project we have right now, this one. Okay, so here you can see that we have like RCC and what kind of framing this is, Karim? Moment frame.
Sir, actually, we are considering the moment framings as well as shear framing arrangements.
Shear framing. Okay.
Yes.
So here we have the moment framing plus shear framing, because you are seeing there are lots of RCC component here that are in center, right? And we have peripheral columns. Got it? So this is the like architecture input that we will utilize to make our whole building. Okay, and see, the model is ready. We are not going to do modeling right now because it's very time consuming. So like refer to these drawings. Okay, so here we have that all the details about that one. So after this CAD file, we will directly go for the like Etab model, right, Karim?
Right,
So
sir.
kindly share the screen with the Etab. Okay, I am see that why we are just going for the Etab, because see the data input, all of you know, all of you having the PDF relate with the all the topic, like which type of analysis we are going to do, and I hope all of you having the basic knowledge about the analysis and design. Okay, so you don't need to refer to the theory again and again. You just need to focus on the practical and how you can implement the things. Got it? So Karim, please share your screen. I'm just enabling you.
Okay, sir. Hello.
Yeah.
Sir, basically, these are the models we are import with the help of center line plan or using the grids. Both options we are using on the behalf of PI generate the model. These all the models will become prepare modelings analysis perform this one. Okay.
Yes. So this is type of high rise and tall structure. So we have the podium level also here, right, Karim?
Yes.
Okay. So all of you know the podium level. What is the podium level in the structure?
Yes, sir.
No? Okay, fine. So what will be the first step that we will do in this project, Karim?
Sir, basically when we enter in the Etab, first of all, our center line plan or how can we judge the structure framing? Okay, these all the work which is performed in our CAD files, sir.
Yeah, after CAD file, we will check our model, right? Right, like our model is okay or not.
Okay, so once we are entering the ETABS part, first of all, we have made to be consider the units, sir. Which units we are perform, like the metric units, imperial units, selecting the code. Code is most important part when we starting our ETAB model. Okay, then import the grids or sorry, define the grids also or import the DXF files. After that, we have need to remove some errors. Sometime what will happen, DXF files create the errors, we have to remove. Then define material, section properties, define elevations. Okay, so and we are moving for the modeling part also. Okay, modeling are performed, then check the results.
So how we can like check the model? Can you brief that one? How you can check the model in the Etab? Kindly show that procedure.
Sir, once we are completing the modeling at the self weight, no loadings. Okay, it means
Okay.
structures no loading part. It means at the visualized picture, we are prepared in our CAD or using the grids as a reference picture, which indicates the structure framing arrangements. Okay, so the members which will become okay or not, we have need to be checked, analyze, and check model. It means our members like the frame, shells, joints, some overlap, someone what we call as a just intersect to each other. So this type of checks we have need to be performed, sir, first of all.
Okay.
Okay.
Kindly, candidate, kindly please unmute yourself because there is some background noise. Okay. Yeah, Karim, continue.
Sir, basically when we moving any type of analysis, okay, first of all our model will become okay. Otherwise, what will happen? We have got a incomplete analysis, stability. So instability remove will become difficulties occurring. So at the initial times, we have removed all the errors in frames, joint, shells. Okay. So we can see that model has been checked, no warning was generated, sir. Okay.
Okay.
So when we prepare the modeling as per the self weight, define the materials properties. So defined part material properties we are defined which type of grades we are considering, concrete, rebar, aluminum, steel. We have defined the type of material as per our requirement, as per our code. Okay, then we have need to define the sections, which profiles we have need to be considered, like the columns, beams, what is the shape, define section properties, frame sections. So all the types of members we have defined, sir. Beams,
Okay.
columns. Okay, it is the frames we have defined. Similarly, we have defined the properties for the slab sections. What is the size of the slab also? Similarly, define the walls also, section properties and wall sections. Okay. So
Yeah.
it means we are prepared the material, section properties, as well as we have defined to what we call as a storage grid system, sir. Modify
Okay.
sugar data. So these, it's also important part. Whatever the type of elevations we have require also. Okay, or define the master story, similar story. Sometime what will happen, our story ground floor it is different. Okay, when we see the
Yeah.
plan it is different, but first level or first to fifth will become similar. It is another plan but not similar to another one, but it's
Yes.
first
Yes.
floor to same to fifth floor plan. Okay,
Yes.
then move for the sixth plan. It is the tower portion will become running. It means the first floor to fifth floor, it is the similar story. First level as a master story, second, third, fourth, fifth, similar to first level. Similarly, sixth story, the master story, or remaining story as a similar story. We have need to be considered. And basically, when we performing the modeling, we have been selecting as per requirement one story or a story, similar story. Suppose I
Yes.
am changing one story, it can reflect all the 1 to 4 story. Suppose I am changing for this story, select the similar story which reflect all the story, not for this one story. So that's why we have considering as per our requirements with the story as a master story, similar story, we have need to be considered.
Okay.
Okay.
So this is the modeling part that we have finished. After that, we will check the model, right?
Yes, our model once we are okay, moving for the which type of analysis we are perform. So basically structure as a free self weight, as a free vibration condition, it means no loadings, no gravity loads, no lateral loads. So how the structure will become response on the behalf of self weight? We have need to
Yeah.
be identify the response on a particular self weight. It means we have performing the model analysis. Model analysis
Model
basically,
analysis.
yes, it is also as
That
a
is
part.
that is the linear dynamic analysis, right, Karim?
Yes, 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 yes.
Okay, so
So
it's an part of linear dynamic analysis, and there is see this vibration. If you see the vibe, this is an kind of, you can say that checking the building configuration based on the self weight with the time period, their frequencies, right? In this one, we are going to check the mode shape, right, Karim?
yes.
Mode, there is three motive to do this model analysis. We have to check the time period, we have to check the frequency, and we have to check the mass participation ratio, like how much mass is participating in, like if we have the first mode, second mode, and third mode, right? So this is just an like uh, based on our, you can say the that is linear dynamics. Okay, so Karim will do this one. Okay, Karim, kindly show the, so all, kindly show the all three mode. Okay,
Okay, sir, basically, when we prepare the whole modelings, determining the response, what is the time period, stiffness, mass participation. So it is a relationship between the what we call the time period in terms of stiffness or the mass participation when we increase in the height also. Okay, so identify the time period on the behalf of model analysis. Time periods we can also identify when you performing the seismic analysis. So initially we are performed with the help of model analysis. So moving for the defined part, load cases, option for the
Yes.
model, modify showcase. So in that part, we have need to be consider how much number of modes we have required. Okay, it is
Yes.
a little idea, 3 multiplied by the number of story, identify the number of modes also. Okay, or selecting the vectors like eigen or the Ritz vector. So in that part, we are selecting the Ritz vector or considering the 45, this one, number of modes, basically 25 to story, this one. Okay, so basically take the when we take the 3 multiply by the number of story, identify, but when we check the frequency also on the behalf of we are cut the number of modes when we performing the dynamic analysis. Okay,
Oh,
so these red vector number of modes when we select this one, we have need to be perform what we call as a structure response is one. Okay, so analyze options, our model will become okay, or static degree of freedom models will become full 3D also, or moving for the what we call as a set load case to run this one. Okay, so
okay.
in that parts basically we are performing on the behalf of model. So basically when we starting our models as a only what we call as a models or the dead load, live load, whatever, as a self-fit only, self-fit. Okay, but we are considering in all of them in terms of dynamic also include, basically we are considering all of them this one. So when you performing this one and run now this one,
Okay.
so the program which will become start, it can analyze also, or we have need to be interpreting our results. So it takes some
So
time
first,
taken.
yeah, so first it will analyze the structure. After that, it will show that if there is any kind of error, and then the model analysis process will start, right?
Yes, yes.
So here, I think, yeah, the model are under process. Okay. So this is the very first step for analyzing the structure, because you have finished the model, and if there is any kind of error in the model, it will show you directly. Okay. But here, Karim, you have applied all kind of analysis procedure. So the structure are checking based on all the analysis. Okay.
Yes, sir.
But in
Otherwise, it
initial
takes,
level,
yes,
yeah. But in initial level, you just
model
need
analysis. Hmm.
just model analysis. If you don't have put the other loads, then also it will work. Okay, it's taking some time. Just wait. Okay. The question that someone asking in the chat, okay, it will answer in the last of session. Okay. So here we have the deformed shape of the structure, right, Karim? And model
Yes.
is analyzed. So did you check model that mode shape? Hello. Yeah,
Hello.
Karim. So model
Yes.
analysis has been done.
Hello.
Yeah, the model analysis is done.
Yes, but basically it's an analysis perform this one.
Okay, so kindly show their like the
One minute, sir.
okay. Kindly not table. So the like their response in the that mode shape. Hello, the animation mode. Kindly show the things in the animation mode. Okay, with the three windows. Okay.
Okay, sir.
So now you are going to see the three mode of vibration that is very like important for any structure. Okay. Mr. Balam, actually we have applied all the loads here. Okay, and this model is 100% ready. So you are asking that what is the necessity of P delta analysis without applying lateral load. So lateral load is applied. This model is ready. Okay, we are not applying the things time by time. It's ready-made model. Okay, and this is workshop. So we don't have such a like huge time to explain that all the steps. You may refer to the previous lecture. Okay, so this is the first mode of vibration. Yeah, all of you are seeing the screen.
Yes, sir.
Okay, so I hope also you are understanding the points. Okay, it will. So, how many people have made like more than one or two model from the training program? Yeah, Karim. Hello.
One minute, sir. I will check it, sir.
There is some problem. Just wait 1 minute. So basically, we are checking this mode of the building structure that you are seeing oscillation in X, oscillation in Y, and there is torsional. Got it? And also we are comparing their like if you see their analysis. I think this all the presentation you all of you have. Okay, and also you have attended their explanation lectures. Okay, so this is the fundamental natural time period of the structure, amplitude of oscillation, and natural time period. We have the natural time frequencies, and this is the formula for that one. So we have right now we have done this. Got it, Karim? Kindly share the screen.
Okay, sir.
Hello.
Hello.
Yeah, it takes some time. Okay. If you
Basically, sir, the
because
models will become some high story. This one, so it takes some time taken to give the animation, sir.
okay, fine.
So in the first mode, the translation is also there, no, sir?
Mode 1 already basically the transitional this one less than 10%. Second mode also this one. Third mode for the torsion is the ideal arrangement, sir.
So in this first mode, there is a translation, torsion is there, no, sir? It is both combined of translation and the torsion.
Sir, basically the window which is some gives a wrong result this one. We have need to add new window once again. Sometimes the problem acting this one. I will show it 1 minute, sir. Just stop animation.
Okay. Okay.
1 minute. This is the first mode. When we start the animation, these are the transitional, sir, not for the mix.
So kindly allows to translate, sir. Wait for a minute, sir.
Karim,
Hello?
it's taking longer time. Yes, now it's fine. Okay, so this is the first mode. Here we have linear transitional, right, Karim?
Yes,
Not
yes.
rotational. Okay, so Mr. Balam, that was some of the Windows error. So first mode is in linear transitional. Got it?
Sir, basically, as a self-weight we are considering, these are the models already prepared. All the other analysis we are include, like the p-delta, buckling, all includes this one. Okay, when we
Yeah.
start, only consider the self-weight, sir.
Okay, so this is the first mode of vibration. Okay. After similarly, we can check the second mode, right, Karim?
Right, sir. Sir, basically
Second-
with the help of stiffness, we are controlling the behavior of the structures. Okay.
Yes.
So depends upon the vertical members, like the columns, walls. Okay. Bracing is also using control this one. What is the positions, section sizes, span also. Okay. Or what is the orientation on the behalf of we are control the what we call stiffness as well, which is very important part in at the early as possible we are control this one, otherwise we are not controlling. So moving for the dynamic analysis, we have need to be revise the framings, we have already applying the loads, we have delete some framings, so as early as possible performing this task in the model analysis, which is helpful also for the total regularity, helpful for the short story, a lot of regularity is also helpful this one. So that's why we are perform this one on the behalf of we are providing the shear walls or columns also this one. We are control this one. Okay. So these are important part.
Yeah. So second mode, what will be the response for the second mode? It will
second
be
mode transitional also this one.
Okay. Transitional and rotational also, yeah, or pure transitional.
Basically starting two modes, which is the pure transitional.
Okay.
Or the third mode will become the torsion.
Okay, so what is the allowed percentage of rotation in the second mode?
Basically, sir, when we selecting the third mode, okay, so the mode 1, mode 2 will become modified in such a way the values which will become less than 10%. When we modify the mode 1, mode 2 will become less than 10%. Third mode basically as per the assumptions, basically as per the judgmental idea, lump sum 40 to 60% acting with one.
Okay, so kindly can you share the that table?
1%, sir, will look at it.
Okay, see, this is some of the like due to the windows. Just show the table. For the high-rise and high-rise structure, it takes time to show the animations. Okay, mostly it will take 5 to 10 minutes.
Basically,
Yeah,
so
Karim.
starting three modes, when we see the RZ values will become less than 10%. It is little bit sir affected, sir. Basically, we are changing some framing this one, little bit
Okay.
affected this one. So basically, these values will become less than 10%, sir. So we have
Okay.
need to revise the framing this one. So the
Okay.
percentage will become less than 10%. So
Okay.
sometime what will happen when we modify mode one? Mode one
Okay.
will become okay, but second mode not okay. I want to
Okay.
changing the framing mode to mode one also change. So performing both modes simultaneously in such a way, both are less than 10%. Third mode will become automatically 40 to 60% torsion.
Okay.
But it is little bit affected, sir. We have need to
Okay.
be taking the less than 10%. Basically, we are changing some framing that way it's affected this one. So it is the first check we have need to be performed when we
Okay.
performing the model analysis, sir.
So first check, here we have some of the value that are 13%. Okay, that are little bit affected. So we need to revise our model. Okay, so after revising the model, then you will get the satisfactory result. Okay, if you do this one, you like people who have practiced these things, they know very well that how they can change the framing their section sizes, or you need to put some of the that shear bond. Okay, so this is the first check that we have done. Now, what will be the next part that Karim we will do?
So once we are changing the framings on the behalf of stiffness, that where we are control this one. Okay, so as per the self weight, we have need to identify the mass participation also. As per the code provisions, the mass participation will become minimum 90%, some 95% if we study the other codes also.
Okay.
So the what we call the mass participation, we can see that in that part we have got the 100%. This one, 100% this one. Okay, but how can we judge the maximum number of modes? If our mass participation cross 90%, we have need to be check the frequency check also. On the behalf
Just
of we have
wait.
need to be cut the number
So,
of modes.
Mr. Balam is saying that first three modes should be minimum of 60%. So, if you have the three number, just let me explain you. One question here, write down here. If you have number, we have three number. Just assume we have number A, number B, and number C, right? And you are saying that all of these three numbers should be less than 60%, right? It should be less than 60%. So saying this statement, it's not saying that your mode 1 should be less than 10%, right? So if you are saying any statement with combined ABC, like three number, mode 1, mode 2, mode 3, then it's wrong, because you have to specify that our mode mode second mode, it should be less than 10%. And here we have the result of that 13% that are we need to change the framing of the structure. Got it? Yeah, Karim. So kindly proceed.
So sir, once we are check the ideal arrangements, mode 1, mode 2, and mode 3, then see the mass participation also, which is cross 90% or not, or 95% is one. On the behalf of we are increasing the number of modes. Okay, it is the second check also. After that, submission for the starting three modes also, which can cross 65% also. Starting three modes, this one. Okay, so this type of checks we have need to be considered. After that, we have need to be identify the frequency. And frequencies are basically we are discussing in the dynamic parts when we moving in the dynamic parts on the behalf of how much number of modes. Suppose we are take 50 modes, 60 modes, 70 modes, 80 modes, this one. So how can we judge, how can we cut the number of modes? Require the frequency check also, which is the 33 hertz. So discussing in the dynamic parts are also.
Okay. So kindly proceed for other step. Okay. See, Mr. Balam, we are not going to discuss the things in very depth or very basics. Okay. We are understanding that all of you have attended the session, so all of you having the enough knowledge to understand the things. This is just the revision. Okay. Yeah, Karim, please proceed. So now we are
basically,
what will be the next thing that we will do?
Sir, these models we are revising some, so some little bit results affected this one. But when we performing this high-rise structures in the previous program, all our results will become okay. So we are changing some framings. That some little bit results will become affected this one.
Yes. Okay. But Mr. Balam, you are saying in IIT if less than 60%, then they would not be accepted. So why here we are not saying that it's 60% or 70%. We are saying that we need to revise the model. And just assume if you are in America, so you don't need to check the things in the IIT. Okay, so there is some international provisions also, but here we are just doing and revising the things. Okay, we are not taking all the things 100% sure, and structure is not 100% sure, because when you are revising the model, they may show you some kind of error. Okay, so here we don't need to worry about that things. Okay, you all of you are engineer, so you need to modify the things. Okay, whenever needed. Yeah, Karim, kindly proceed for the further process.
Sir, once we are completing the model analysis in terms of self-weight, identified stiffness, mass participation, these are the checks we are applying. On the behalf of we are providing the columns, modify or shear wall, this one, these are all the part we are cover. It means our models, no loading, no gravity loads, no lateral load factors, sir. Okay, moving for the loading part. Loading basically is the external force. When we applying the external force, what is the structure response? So loading can consider the gravity loads, lateral loads, different types of loading, gravity, point of view, dead load, super dead load, dive load. We have need to be calculate or apply in our model.
Okay, so we have already calculated that all the loading part. Now we are just put the gravity loading, right?
Right, sir. So in that part, we have need to be define the patterns, which type of loadings we have need to be considered. Dead loads indicate the self-weight. We have already taken super dead loads as external loads, some finishings also, live load also. So depends upon the requirement, which type of gravity loads you are consider. We have need to be defined the pattern, sir.
So okay. This is the load. This is the load combination.
Load patterns, load combination takes later also. Okay. So whatever the loads we are considering depends upon the code provision, sir. When we using the Indian standards on the behalf of IS 8875 part 1, we are calculating the super dead load. It's a branch for the dead loads, whatever the type of finishings, what is the masonry, identify the thickness, density, we are calculate or apply also. Okay, so live loads for the part 2 we are considering. Live loads basically we are not calculate as per the code also provide as per the occupancy point of view, we have need to be taken or applied. So depends the type of framings, depends upon the occupancy, like the kitchen, bathroom, if buildings residential, we have to be considered. So okay, code also provide this one.
Yeah, so you can refer to the code that you are, which code Karim you will consider for the loading. We have national and international code also. Some of people, yeah. So here we have some of the training member like Mr. Assis, and like you have also seen the things with the American standards. Okay, but here we are using the IS standard. Okay, we can do with the other codes also. Okay, for the loading, putting the loading. So after putting this gravity loading, what will be the next procedure that we have to follow?
Sir, loadings we are using like the Indian standards or American standards, both are similar, sir. But the difference only the thickness of the material depends upon the type of material and the density. We are calculating both are same, sir. But okay, that material thickness test will be different, sir.
Okay, fine. So after putting the load, what will be the next procedure?
We are calculating. Okay, we have to be selecting the frames, select the beams, or apply the frame loads. Okay. We are applying, then moving for the area load also and the shell part also. We have defined the set also. Sets also defined like the gravity loads, bathroom, kitchen portion defined or apply in our model, sir. Okay, so in this way we are applying the gravity loads. We are moving for the lateral load also. So lateral loads basically we have defined the patterns, similarly defined patterns. So basically lateral loads which is divided in two parts, basically the seismic or the wind, both are critical parts.
So here we have the EQX, that is which method you are applying for linear equivalent static method.
Right, sir. Okay, so depend upon the code provision, sir. All the load we are calculate, consider as per the code provision, sir.
Okay, and this EQX and EQY is the what kind of load this we have?
These are static loads we are considering. Okay, as per the IS 2093. When you modify this one, all the parameters we are considering as per our code provision. So buildings location, seismic zone.
Yeah. So that is the seismic zone factor, the site type, the importance factor. that you have to define throughout the course, and after that we have to apply on the model, right? And after applying this seismic and this what you can say that gravity load, what will be the next procedure that we have to follow?
Basically, sir, in a linear static analysis, we have made to identify the base shear. So
Base
base shear basically different types of gives a different formula. Like the Indian standard also, VB equal to AH multiplied by the seismic weight is one, or study the ASTE, UBC. So basically all the codes we are extract the base shear values. Okay, so depend upon the code provision, which codes we have need to be considered on the behalf of we have need to be put up the data. Like the what is the seismic zones, site type, importance factor, time period, we have to be considered or put up this one. So it can calculate the base shear values. When the earthquake strikes, the unbalanced vertical force will become generated. We have required the base shear, which can which will become equal to which is balanced to unbalanced vertical forces. Otherwise, our structure will become collapse. So we have need to be put up the parameters in this templates. When we performing the analyze our models, we have got the base shear values. When we create the report, also identify the base shear also. So it can give the base shear. Okay. So as a linear static analysis, we have need to be considered this one. And
Okay.
also define the mass source also. It is a mass source also. We have need to be considered this one. Okay. So when we moving for the mass source, or when we unlock the model, we have need to define the mass source also this one. So mass source basically, as per the code provisions, your intensity of the loadings, we have need to be considered 25%, 50%. We have need to be defined also this one.
Okay.
Basically, we have unlocked the model or put up. Basically, it is
So
not showing this one.
why we are doing this mass source?
Mass source basically when we consider the what we call as a seismic weight also. It's also helpful this one, sir.
Okay, fine.
So base shear values we are considering like the horizontal acceleration multiplied by the seismic weight is one. So we have need to be considered, or this is also helpful for other types of analysis, looking for the P delta also, other type of analysis we have to be considered. And code also says that we have using the mass
So
source
what?
also.
So what is like next process after putting these loads?
Okay, so these are the patterns we have need to be defined. The load patterns we have need to be defined for the what the static analysis is one. Okay, moving for the dynamic analysis also. In that part, response spectrum we have performed this one.
Hello, Karim. After applying this gravity load and lateral load, what will be the like check on the structure?
Basically, sir, once we are applying our models, okay, structure will become with a deformed shape.
Okay,
When
so kindly show the see after you have applied the gravity load and that equivalent static method. Just after that, we have to check the structure deformation, right? So
Yes.
check the structure deformation and their result.
When we
So
selecting
there-
any particular
yeah.
case, sir, okay.
So here
Or
we are putting first of all the case, the load case, right? And we have to check the deflection.
so we can see that the structure will become deformed as one. Okay.
Okay.
Or when we see in our 3D models how much structure will become just what we call as a deflect as one as per the gravity point of view this one. Okay. So we have need to be identify the particular story, how much amount of deflection for the gravity. Okay.
Okay.
So which
So
can
what
give
will
the
be
values used at.
Is there any kind of provision to check that minimum deflection?
Basically, when we study about the IS standards, the deflection also, okay, I think it is the span by 250 this one, the formula will become, okay. So identify that deflection also. So the gravity deflection we are control, like the modify the slab also, modify the nearby members also, this one, we are control this one. So basically deflection we are control, we are exporting our slab in safe, sir. Okay. On the behalf of we are performing some checks also, like the short-term deflection, long-term deflection, other types of checks we have applied, or in the safe we have modified this one with the help of.
Okay, fine. So now after checking that deflections, okay, what will be the this is the undeformed shape. So is there any kind of table to check the like deformed shape and any
yes,
kind of
yes. Moving for the display or move for the deformed shapes. Sorry, store the response plots. So the case also consider combinations also available. Suppose when we considering the displacement or when we check the in terms of that, suppose we
Dead load.
have need to be identified as well. So tables
Okay.
also using. So in that part will become showing this one. I want to check in terms of the data also. So
Okay.
story will become showing for base 225 level this one along X deflection. So
what is
we
the
can see that
maximum? Yeah, what is the maximum allowance for the
2.5.
story distance?
Basically the maximum values will become 2.15 this one. It means 2.15 deflected in the 25th
And
level.
what is the maximum allowable value?
We have need to be check the deflection, sir. Basically to
deflection,
control of
The
deflection.
maximum, what is the maximum allowed deflection?
We have need to be identified in terms of span, the span divided by the 250. It is a formula also, sir.
Okay,
So this
span
type of
by
deflection span by I think 250.
250. So if we have the span is in meter, mm.
Yes, we are changing in mm also.
Okay, so if we have, just assume if we have to check for the 25th story. So the 25th story height, it would be 25th into 3 meter. Just take the height of the story.
Sir,
We have the 3 meter.
Sir, basically, suppose our plan this one. Okay.
Okay.
We have need to be export in safe. I want to check the
No,
deflection.
I'm just asking you that if we have whole
Yes,
structure,
yes.
that we have the 25th story. Okay, so what will be the maximum allowed displacement here for the 25th story? That is span by 350 or other formula.
The formula will become same, sir. Span by
250.
this one. Yes. So which is gives the allowable deflection. This one we have to be considered. So this
So
type
if
of
we have the 75 meter here, right? So 75 by 250, right? This is the maximum allowed value, right, Karim?
sir 74. It is the height, sir. Hello.
Yes. So we are okay, fine. So you are not saying in terms of height, you are saying in terms of width.
Yes. The slab
Okay,
basically. What is the spans we have to be considered on the
So
control.
here for the 25th story or any story you are counting, so it's allowable displacement under control.
The control deflection we have to be considered, like the
No, I
span.
am just wait. I am asking you that our result is satisfactory or not.
Sir, basically we are exporting in the safe to performing the deflection, short-term deflection, long-term deflection. This one, okay. Basically identify the deflection in the slab. So these are the deflection portions showing this one in the members. Identify the deflection we are performing the slab export in the safe or different types of checks apply on the behalf of your control. Our allowable deflection, it's okay or not.
Okay, so we will check the things in the safe. So after this one, what will be the next procedure after checking this story response?
So finally, it is the gravity deflection. If you want to interpret our results on the behalf of direct load, super direct load, take the combinations also. So identify the gravity deflection this one. Okay. Similarly, whatever the case we have to be considered for the EQX this one. Along the X direction, we have got a 29 mm this one.
So 29 mm is the allowed value.
It is give the maximum values as per the core provisions. We have to be taken H by 250. This one H by 250. This one
H by 250. So if we have 75 meter height, okay, and
into
250.
75 multiplied with 1000, changing mm also.
Okay, 1000. Okay, fine. Okay. Yeah, so it's under control, I hope. Okay, because it will be if you calculate, right? So the height of the building is just assume 75 into 100, right? And dividing by 250, right, Karim?
Right, sir.
So we have 30 mm. Okay, so it's less than 30 mm. If you check, yeah, Karim, it's less than, because here we have, right, this one. So it's less than 7, that is 30 mm. So it's under control, right, Karim?
Right. Similarly, sir,
Okay,
we
fine.
are check for the EQY also. The formula when we consider this one.
Just wait, I am checking. Yeah, Mr. Pankaj Verma, I am just checking. 75 into 1000 divided by 250.
300
Is it?
mm, sir.
Oh, okay, sorry. Sorry for that one. 300 mm is the maximum allowed, and here we have that is just the what is the value? That is
Long by
less
21
than.
mm.
Yeah, this is very like under control. Okay. So this is for the EX, EQX, and EQY, right, Karim? So what will be the next procedure after checking with the static equivalent? Okay, yeah. So Karim, please move for the other loading type and check the response.
So in this method, the gravity deflection, lateral point of view, we are interpreting our result as well. Okay. So gravity deflection, if you want to see, we have need to be performed in the safe, sir. Okay. On the behalf of performing some other checks also. Okay.
So, no, just here, just complete first of all the Etab part. Okay, then we will move to the safe. Okay, so what after putting this static equivalent method, like we have that RSM method. So can you please elaborate about that, like how we can put that RSM response spectrum method?
Sir, when we moving for the dynamic analysis, okay. So in that part, we have need to be defined in the ETABS RSM, sir, response spectrum,
Okay.
sir. Okay.
Fine.
So define the functions, selecting the code, which codes we have need to be considered, modify the spectrum, this one. So whatever the.
So all of you know this graph. This is the ground acceleration graph, and this is the envelope, that is response envelope. Okay. So whenever any seismic activity is going on, if you see this, if you are seeing this graph, so exactly this is the mean of that graph. Okay. If you see their like, if you see the earthquake and their responses, so generally it will like very very fine. Okay, it will like this. Okay, but we are taking the ground acceleration with one kind of fixed value. Okay, that is the mean. Okay, this is the, like, you can say this is not the exact value, but we are taking mean of that one. Okay, so this is the envelope, that is the function envelope for the ground acceleration. Okay, you all of you know the seismic zone factor, impotence factor, soil type. Okay, so based on that, we are going to do the response spectrum method. Okay, with some kind of fixed value. So Karim, this is under linear analysis or non-linear analysis?
So RSM part we are performing as per the linear, this one, dynamic response spectrum, this one.
So this is linear, right? Got it. So please apply the load and check the response against this RSM. Hello.
Yes, sir. All the parameters we are considering as per the code provision. Like
Okay,
the
so we
static
have,
analysis
yeah, got it. So kindly proceed further, because we don't have such time to cover that all the things. Okay.
Once we are defining the function, we are moving for the cases. Okay. When we considering the cases, the load with respect to time, called as a load case, but the pattern which integrates the intensity load pattern, it is a load case. We have defined the response spectrum RSX. What if I showcase this one?
Okay, so here we have that load case data that we
Yes.
have put.
Here we have selecting the type, so it is the most important part. Which type of analysis need to be considered? Selecting this one, then we have need to be define the loads apply. We have perform the acceleration along the x direction. We have need to be consider RSM, calculate the scale factor also, or you can also revise the scale factor also, this one. Okay, or performing what we call as a methods also, like the CQC, SRSS, lots of methods available in the theory part available. Okay, so we have need to be considering the methods. Then the damping, what are the damping we have need to be considered, this one. So all the parameters we have need to be considered. It is a case one, or RSY similarly also we have need to be defined. But
okay,
then
so
we moving for the RZ also.
So we are applying for RX, that in X direction, Y direction, and Z direction also, Karim.
Yes, basically code provisions also, revised code also suggests that we are taken the 2/3 value this one as per the
Okay,
gravity
fine.
point of view. We have need to be considered. So three cases we are defined RSX, RSY, and RSL. Okay. After that, we have need to be analyze our model or interpret
Yes.
our results. But in that
Okay,
part, we
fine.
have need to be interpreting our results as a dynamic behavior. Okay.
Okay.
So we have need to check the lateral displacement on the behalf of VI. We have need to provide the shear wall or not. The lateral displacement suppose along Y will become higher. Basically, dynamic load will become acting. But
So
before our
after,
model,
yeah, so after applying this load, what will be the next thing? What we
we
will
have
check
need
for that one?
move for the displaced to response plots. This one.
Okay. So again, we are going to check the story response. So basically, we are just checking there, like again the displacement, right?
Sir, basically, when you perform the static analysis, okay.
Yeah.
So in that part, which is the case this one, static analysis this one. Okay. So in that part, all the unbalanced vertical forces which will become distribute top to bottom. We have got the base shear values also. Okay.
Okay, fine.
So as per the static analysis, EQX, EQ, but moving for the dynamic part also, the lateral displacement, maximum fluid displacement, we have need to be checked that the case for the EQX, we can see our result will become okay, 300 mm is less than, or RSX this one, the case will become, we are seeing this one, which is very, very less value, 1.84 this one, sir, values this
Okay.
one.
So according to this analysis, we have like our model is ultimately it's fine. Okay. Checking with the Rsm method. Again, our structure is okay.
Basically, sir, once we are checking the lateral displacement, the important also, it is story stiffness also. Story stiffness, basically the below story, which will become high stiff as compared to above also.
Okay. It means our like bottom story, it should be
Yes,
maximum
higher.
stiff.
Yes, which as
Okay.
compared to above.
Why? Because see, I have discussed these things like in our many batches. Okay, our this is just like if you have the maximum stiffness of the base story, then it's like it's good. Got it? Because the maximum load we have on the column of first story. Okay, so first story should be maximum stiff, right, Kareem?
Sir, basically, as a picture, this graph indicates the picture. Our results will become okay. The stiffness below will become high. Suppose our stiffness will become less as compared to above. What will happen when we check the soft story? So results not okay, sir.
Fine.
So that's where it is the important part. We have need to be
Okay.
see the story stiffness along the X or Y also this one. Okay.
Yes. Yes.
So we have to be interpreting our results this one. When we using the Excel sheet also identify the soft story, heavy story, mass. These are the regularities this one. So first of all, we have need to be see the picture. Our result will become convenient or not. Sometime what will happen, the section size for them will become high stiff as compared to below. So in
Okay.
that part, the story stiffness for the upper will become higher as compared to below. So the
Okay.
member size we have need to be taken for bottom to top, high stiff to less stiff. The axial force
Okay.
will become acting for the bottom will become high. Okay.
Okay. Fine.
After that, we are move what we call as a drift also. Okay, story drifts.
So this is all based on the loads that we have applied right till now.
Okay, so these are the story drifts also acting. We have also calculated the
Hello.
formula.
Yeah,
Hello.
Karim. So you are taking for the EQY. Can we take another load pattern? Yeah, not this one. Kindly take another one like that.
RSX also available.
Yeah, RSM. So here we are checking the maximum story drift based on the load combination that you have put on the structure. So again, it's okay, Karim, because I think the nature of the deflection of like a story drift, it's fine.
So it is the formula also. The code
Yeah.
says that 0.004 multiplied by the adjacent story heights. We have to be consider this one.
What is the
So it
formula?
means 0.004 height, kill height.
0.
This one 0.004
004
or multiply it is the clear height also. This one we have need to
height
be
of the
identified.
story.
Yes, clear height is one 3 meter, 3.2 meter, whatever this one.
No, I am just asking you that if we have to check that our 25th story is okay or not. So how you can check?
clear height will become 3 meters, sir.
Okay, we just need to calculate that 0.004 into 3 meter. That is the
Yes.
maximum allowed drift, right?
Yes.
Okay,
See,
fine.
our result basically will become less, sir. It is very, very less value, sir. This one.
Okay, fine. So if
So-
we calculate, can you calculate any result in calculator?
Yes.
Please calculate any story for any story. Okay, like that is 0.004 into 3 meter. Hello. We are not
Hello.
seeing the calculator, Karim. Yeah. So here we have 4 into 3. So that is 0.012. What is the value in mm?
Yes, sir. Basically, when you performing the irregularity checks, okay, like this story, how much deflected, or this story deflected, we have minus this drift to this drift, or
Okay.
divide by the h also.
Okay.
So when you performing the irregularity, we have need to be check also. So this story will become deflected some amount. This one,
Okay, fine.
or this story deflected some amount also. We have minus both drift. We have got the value sum. Or this value divide the it is the h also. We have got the drift also this one. Okay,
Okay,
story
so it
drift
means
also.
drift of like below story minus drift of upper story divided by what will be the things? Can you write down the exact formula, Karim?
Sir, can we open the PPT sir this one? Some formula we have performed this one.
Yes, because I think this is the important part. Okay, so we need to focus on that one. So candidate can type in the chat box that all of you are understanding the point. See, there is lots of like issue you can find with the model and the things, but don't worry. Okay, if you refer to our previous lecture that has been taken in the regular class, you can easily interpret the things. Okay, this is just the refreshment of your knowledge. So people can training can type in the chat box. Hello, because there is some background noise is coming from trainee. That's why I mute all of them. So you can just type in the chat box, so I can refer. Hello, Karim.
Well, sir.
Yeah, Mr. Jisan Ahmed. Jisan, and we have Mr. Pankaj Verma, Neeraj Verma, Manan Soni, Harish Kumar, Ashish, Mr. Balam.
Hello.
Yes. So here
Sir,
we
these
have
are
that. Yes, this we have.
Sir, first of all, we have checked the total drift is one.
Okay, fine.
At by 250. So our results will become 300 mm. Okay. Or moving for the story drift also this one. So when we consider the upper story this one, or suppose moving for our building in this terrace parts, we are moved the plan this one, or show deform shapes. The case we are considered apply this one. Suppose we are taking this 1 points, which will become x direction 28.949.
Again, we can check for the another story, right, Karim? Moving
Yes,
down.
it is the 24
fine.
level.
Yes,
it is a displacement 27.779.
Okay. It's very interesting things that like This is very okay. So we need to
Okay, it is the upper story or the below story, it is the 24, this one, minus
okay.
this values.
So all of you are getting the points. Hello. You can unmute yourself. Hello. Okay, fine.
The values will become very less, sir, 0.47 this one.
Okay, and Mr. Ombi, you are getting the points.
Yes, sir, I'm getting the point, sir.
Okay, fine. So have you practiced this all the things in the training, or you have just missed this all the parts?
Yeah, I was there during the classes, and I'm trying to practice, sir.
Okay. So these are the checks on the structure that is very like important. Got it? So yes, after this one, Kareem. Yeah, so
Hello.
this is the find value. You can skip now. Okay, we got the point. After that, what will be the next thing that we will do in the structure?
Sir, basically, the story drifts we are calculating this one. The upper story, below story, adjacent story, we are calculating this one, or interpreting our results also. This one.
Okay, fine.
Okay. So, performing the dynamic analysis, identify the lateral displacement. Okay, story stiffness, story drift. This one. Okay. So these type of checks we have to be considered, but we are moving once again for our dynamic behavior.
Okay. So
Basically,
like if we have such kind of like that geometrical irregularities or the nonlinearity like P delta, that all things how we can do after this one?
so these are the linear dynamic analysis we are considered. Okay. So other parts, which is the geometrical in shape analysis,
Just
the P
wait.
delta.
So just wait 1 minute. Yeah. Here we have the list of, kindly say stop sharing screen, Kareem. So this we have that analysis, right? So now up to now, what kind of analysis we have performed? This one, right? This one also, Kareem?
Yes, sir.
No, no.
Non-linear static is the pushover part. We take more time
Okay.
taken, sir, in this or construction stage. This
So
one.
this one we will apply on the 2D frame. Okay,
Yes,
due to
it
the
takes much
time
more time
consumption.
taken.
And similar step you can follow for the other structure also. And construction sequence analysis, it will also take
Yes,
time.
yes, it is a part
So
for
you
the
can,
yes.
if you have the smaller model, you can show on them also. Hello.
Hello.
Okay. So what will be the
Yes.
next analysis that we will perform?
Sir, moving for the P delta also.
We have this time history analysis right now available
Yes,
in this
yes,
model.
yes. Time history
Kindly,
also, sir.
okay, so kindly show the animation and that responses
One
for
minute,
that.
sir. I will share the screen, sir.
Okay, just wait.
So when we defining the time history analysis, so define the functions also, the time history, this one. So in that part, we have need to be performed, select the from file. So when we selecting the function, this one, take the previous earthquake record data. Okay, so time history, we are considering modify show function, this one. So previous earthquake record data, we have need to be taken this one along X, along Y, we are considered. Then we have need to be define the target response spectrum also. Then we are moving for scaling also, match to response spectrum, this one. So we have already defined this one, matching also this one. Basically, we are using the linear, this one. You can also consider non-linear also, the FNA options also available, and direct integration also available, this one methods. We are using the linear model also. This one, scaling this one also, we are match
So,
also this one.
hello. Basically, see this time history method. It's very like research and very deep, very much in deep. Okay, the people who have missed this part, like we have in one batch, we are going to start from the Monday. This time history method. So it will take for the theory classes. It will take like 4 to 5 class to explain all the procedure for the time history. And time history we have linear and non-linear, and it's very very much in deep. Okay, if you study this time history method, it will take time to understand the things and the point. Here we are just applying the things here to check our structure response, right? So after applying this all the process, what will be the next thing that we will do, Kareem?
Sir, define the functions, define the scaling or matching also. We have
Okay.
need to define the case again. Define the load cases, selecting the linear model, this one. We have define the case, which is this one, model show case.
Yes.
So in that part, we are selecting the
So
linear model.
we are doing the linear time history analysis, right?
This one, sir. Non-linear
Okay.
also consider this one. That is the other part also. We have need to
Okay.
be taken the simultaneously U1, U2. Skill factor you can also consider. Otherwise, you have to revise also.
Okay, fine, fine.
Okay. So once we are considering, we have need to be interpret our results also. 1 minute, sir.
Okay, so now we are going to apply the time history method in our model, and it's very important to check the responses. And I will share you one sheet, not sheet, the form to in the group. So there you can put your questions in detail. So we will able to understand that exactly what you want to know. Because sometimes what happen, this is very critical process. Okay, there is lots of things that involved in the program. So sometimes we also didn't get the candidate what the candidate is asking. So it will be better if you email us about your doubts in details. Okay, because after that we will discuss the things and we will give you the perfect answer. Okay, because the live session discussing lots of things, it may be little bit difficult. Okay, so please write down the email like training@structurex.in and you will get the answer if you have any kind of major doubt. Right? So here what we are doing, Kareem, checking the structure.
Sir, basically we are selecting the time history. The case will become active. We are need to analyze. Basically, the previously we are pick off the case time history. That's why results not showing. So
Okay.
we are take on the case time history run once again. So,
Okay,
okay.
fine.
On the behalf of we are interpret our result for the time history like the scaling base shear also. Okay.
Yes.
Response spectrum we are perform scaling the base shear. Basically 85% cross, sir. The
Okay.
scaling base shear as per the ASDE or Indian codes also you are using. Similarly, with the time history need to be scaling also. Both of them we are performed in time history as well as response spectrum. Okay, we have need to be combined results also. Combined results basically the stored displacement, stored drifts, stored shear. We are interpret our results once we are completing our analysis. Okay, and also we have got the how much amount of base shear required as well in particular time history analysis.
Okay, so here the structure are under analysis, right?
Yes.
And people who are comfortable to open their camera, you can. Okay, because seeing the candidate, it will give us the confidence. Okay, because only seeing the voice and seeing the screen, it will be better if you on your camera. Okay, so we will get more confidence. Okay. Okay, so Mr. Pankaj Verma, thank you, sir, to open your camera. Okay. Here we have Mr. Ombi.
So finally, sir, when we performing the like RSM part, THM part, scaling base shear also, sir. Okay. So 85% also plot this one. Then we are moving for the combined story response plot also. This one. So at bottom parts, it is showing some graph also. The structure gives the deformed shapes, basically this one. What is the behavior, or when we see our results in terms of displacement, the drifts, shear also, or
Overturning.
water-ending moment is one. Okay, so in that part, basically the structures gives the behavior. The red lines or the green lines, which just gives the maximum to minimum, this one. The blue lines indicates the structure behavior once
But
we are
Karim,
performing the animate.
one question that how we will get to know that this is fine, the result we are getting is okay.
Sir, here the values available, sir. You can see the
Okay.
values which will become the displacement, those ones.
And that is same on the previous judgmental formula.
Yes, code gives the same provision, sir. Like the displacement values as per the IS 1893 as by 250. So seismic
Okay.
part basically. So time history also is a part for the seismic analysis, sir.
Okay, fine. So this is the that displacement, that is a story displacement, the story drift, their shear and overturning. What is this overturning? It means this is in torsional mode, like that.
It is the moments portion, this one. Basically
Okay.
gives the overturn, this one. At the bottom
Okay.
portion, sir, we are see it is some
So
graph just showing up and down.
can we see in the 3D model also this overturning? And your below graph is not showing clearly. Can you please down your screen? Hello. That input function. Kindly that keep that file in the above. We are not able to see that one. Okay, I think there is some display. If possible, Karim, kindly show the animation in the 3D model for the
Okay.
overturning that.
Sir, basically, we have got the results with the help of story response plot in the dynamic analysis. But when we see the behavior, we have need to select in a particular case. Moving for deform shape, just deform shapes. So in that part, we have need to be selecting the case, which case we have need to be considered this one.
So only deformed shape we can see, or the 3D model also we can see.
So when we selecting the particular case, structure gives a deformed shape this one, sir. Like the EQX, EQY, RSX, we have need to be considered gives a deformed shape.
Any type of animation available for this analysis?
Which animation, sir?
Like if we are applying the time history method, so we can check their responses in 3D and 3D animation.
In 3D analysis, sir, we have need to be selecting the case.
Okay.
Suppose the time history we have need to be selecting or apply this one. So structure gives a deformed shape this one. So finally,
the
yes,
animation is under process. Just wait. Okay, so it will just give the that deformed shape. Okay,
sir, finally we can say that when we define the pattern, define the load case, it means we are able to see the deformed shape.
Okay, fine.
Or combined results also, interpretable results also.
Okay.
Or second thing is that when we moving for display, once more, sir, it's just running in motion.
Okay, so it will give the 3D animations. Okay. Just wait, and just Karim, just I am sharing another screen. So after this one, time history method, we can apply both in the linear and non-linear, right? All of you are now seeing my screen. Hello, Karim, you are seeing my screen.
Yes, yes.
Okay, so this time history method, like we can do it with the linear and non-linear also. After that, we have the wind, and after that, we have some of the checks. That this all kind of things that we are going to do right now. Okay. Okay, Karim, again share your screen.
Okay, sir. So, sir, once we are complete the time history, define the functions, load cases. Okay. So, if we moving for other analysis like the P delta also, okay,
Yes.
or moving for the wind also, sir. Okay.
First
So,
check for the wind.
okay. So, moving for the load patterns, we have need to be considered. So winds we have need to be considered as a lateral force. So code also important part in part.
Okay.
So selecting the Indian standards IH875. Okay. So the code provision we have not to be considered, but we are using for the user loads will become better or accurate method this one to control our structures using the wind coefficient method, wind gust factor methods. It is long procedure to calculate manually or pace the point loads along the x direction, y direction, and the moment is one. So force coefficient or gust factor methods both are considered. Indian standards available the formula. It is a long procedure with the actual chips were calculated or put up also. Using the American code also, different formula also available. You can calculate manually also. Wind tunnel also calculate
Wind,
the point load
wind.
you have got.
Karim, can you brief something about the wind tunnel test?
Sir, wind tunnel test basically when you perform we have basically we have got the results just providing by the wind tunnel supplier
Okay.
give the results also. I have a one sample. I will open it, sir.
Okay, please. So, like see, we are putting the wind that wind load in the structure that is with the coefficient and gust factor. But there is new thing that is called the wind tunnel test. I have repeated that one in our last like in yesterday's session. And here we are going to check that one again. But this is just a briefing. We will see this thing in detail also. Okay. And the people who need this briefing video, okay, they can message me. I will send this video to all of you. Okay, the previous recorded session of this wind tunnel test. So you can refer in the better way. So this is the wind value. Okay, Karim, that we have from where you have got from the testing agencies, right?
Yes, yes, sir.
Okay.
I will open it, sir.
Please don't mark on the whiteboard.
So my screen visible? Hello.
Yes.
So, sir, basically when we study the CTBH, this one testing for the high-rise building or study the ASC-716, this one. Okay. So in that part, it can performing the test in the workshop. Okay. So in that part, basically we have got our result at forming the identify the wind speeds like the geographical conditions, whatever the category of the wind when we
Okay.
when
This is from the data input from the laboratory, right? Or
yes, yes.
you can see this data on the like on for the India, that is the like you can check on the meteorological website. Okay, that is provided by the government of India. There you can find this kind of data for the wind speed, what is the current wind value. So this is the 360 view of the wind, right, Karim?
Sir, basically when you make the wind analysis, code gives the conditions, code gives the map, how much amount of wind speed in meter per second, miles per hour. This one, we are taking the values for the wind. But
Okay.
when we coordinate to wind tunnel department, it can perform
Yes.
the wind testing in by its your own. Okay, so like a red rose wheel, this one. So it can identify the what is the wind percentage, this one. Okay, we can identify this one. So it can perform like the wind criteria, this one, nature of wind effects, it can perform, or it basically we are provide the our FEA model. These are the examples showing this one. It is the wind tunnel tube also. In that part, the frequency, some frequency just acting this or just tilting this one 0, 10, 20, 30 degree or interpret our results again and again. So it
So
can
have
give
you,
the
Karim, have you applied this thing in this current model?
Basically, sir, we have got the data from this department or
Okay,
apply.
fine.
If we performing this one, we have need to be coordinate to this department also, or go in this department or performing the work this one. Okay. After that, we have got the results like this. So you can see these are the wind direction or
So
base
we
moment.
can check this in the ETAB also.
Sir, basically these all over the data provided by the wind tunnel. We
Okay.
aren't able to perform in the ETAB this one. If we using the other software to look like the R-Wind also this one, we have performed this one. But the results we have got, we are applying in our model, sir.
Okay. So after going with the result, we can apply in the model, right?
Okay, so a lots of graphs it can obtain, like the wind tunnel department is one, or we have got results also. The results,
Karim, can you show in the ETAB this effect?
sir, these are the results available.
Okay.
Okay, like the different types of story you can consider, or
Okay.
we are just considering this applying our model also. Okay, or moving for our models or define parts, the load patterns, this one, or we have need to be consider, we have need to be defining the fx
Okay.
fy,
According
this
to
one.
that, you have applied this data, right?
Okay, like the wind coefficient method, wind gust factor methods, we are calculating manually, sir. Okay, or paste this with the other of Excel sheet. Similarly,
Fine.
we are coordinate to this department. If the Excel sheet also, we are coordinate this department or apply this one, then apply in our model or analyze our models. Once we are apply or interpret our results also, like the story displacement, we can see in the seismic analysis, we can see the story response plots.
Yes.
But in that part, we have to select the pattern for the wind. Selecting the wind part, we are selecting. So which will become very less values. We have got 8.462. 8.462. But when we see the displacement values, we have got H by 500, sir.
Okay.
But seismic analysis, H by 250.
Okay.
But
So
when
this
we
we have
using
to
the
check. Yes, please.
But sir, when we using the American standards, so seismic got the wind, we are considering H by 500 this one. So in that part, we have to interpret our results also. This one, our lateral displacement not allowable.
So it's
high values.
okay. So it's under control. I think that is H by 500. That is very like large unit. But here we have minimum amount that is approx like between 7.5 to 9. Okay, so it's under control, right, Karim?
Sir, what will happen? Our displacement will become higher. How can we control this one? Okay. Basically, we are providing the stability in our structures. We can provide in the shear walls also, or different types of arrangements we are considering to control this one also. So wind analysis, we are considering like this.
After checking the wind analysis again, we will check the deform shape.
Yes. Moving for the deform shape also. Particular case, we are selecting the case for WLX or apply also. So structure gives the deform shape in the particular along.
One question that I have in mind, that this is just showing the deflection in. Okay, it's showing the deflection in now in transitional, like in X or Y direction, right?
Sir, you can also interpret our result with better story response plots, or when we select the case.
So now we have this is the deflected structure, right? Okay, that we have this story displacement, right, Karim?
Yes, sir. Sir, we can also identify with the help of tables also, WLX tables. So you can see, sir, along the X direction, base 0. So deflection will become for the wind. Maximum values, we have got 8.462 at the bottom part, this one. So 8.462 this one, maximum this one. But little bit affected along the Y, very less this one. Or this sheets we have also exported in the Excel also, this one. So the tables also using, graph using, or 3D model also interpret our results.
Okay. So this is the story maximum story displacement we have checked for this high-rise model. After that, like we will move to the our further process. Okay, and further that Karim, is anything to show with this wind?
Yes, sir.
Any table or any kind of more graph that we have to check for the wind analysis?
Sir, in the wind part, we have got the base shear also. We have got the lateral displacement, this one. Okay, tables also available. How much amount of force will become acting this one.
Okay, you can see, you can either check the table or check the
Okay, so
that
a lots
graph
of
also.
results we have to interpret. Basically, how the wind will become acting this one. So tables also available or response plots also available. So when we selecting the particular only wind, sir. Okay, only particular wind. Selecting the WLX. So sir, you can see how the wind will become acting when we selecting the keyword WLX, this one. Sorry for the seismic point of this one. It is the displacement values WLX, this one, or story showing this one.
Okay, so this is the table we can extract from this analysis, right?
Okay,
The story.
so with the help of sir, we are interpret our results also.
Can we check the
Displacement.
overturning moment also?
There's overturning moment showing this one. The moment will become showing this one.
Okay.
So basically, what will happen when we performing the irregularities, like the torsion irregularities also. Okay, it's also important check, sir.
Yeah, Karim, please see. After this one, we will move to our some of the nonlinearity checks. Okay, that is first we will go for the P delta and Karim. This model is also for the buckling analysis. Are you able to perform right now?
Yes, P delta, sir, we have to be selecting. Basically,
Okay, P
sir,
delta.
first
See, just wait. I am sharing the screen. Another screen here. So now we are going to do this one because we have sort of time. We have to move fast for this one. So can you perform this P delta buckling, grip shrinkage? Okay, and this axial column shortening analysis. The analysis we have left, kindly finish that one. After that, we will see our. See, today we are not going to cover the substructure because sort of time. We will give you one that report on this project. Okay, so you can read that one. In our upcoming workshop, we will finish our that is called the substructure and foundation. Okay, so Karim, please go for the P delta. Okay,
okay, sir.
so P delta is a geometrical nonlinear analysis. Okay, they generally like yes, Karim.
Sir, sir, basically using the Indian standards, code silent IS 1893. Okay, so we are using the American standards, identify the theta values, the secondary moments, the primary moments will become higher values or not. It's a formula available. Basically, we have need to be calculate also, interpret our results. We have need to be apply or not. So we have no need to know define the P delta. If our values cross the theta values higher, we have need to be defined. In that part, we have need to be taken the patterns, take the scale factor. We have need to be considered. So it means it can take the scale factor this one. We have not to be considered, sir. Okay. So when we performing the P delta, it means it takes the stand when we using the in changing the geometry. It can include also. So it is a formula available. We have need to be using also. So can I share the window, sir, for P delta?
Yeah, now
from
you
the
can.
formula.
Yes, now you can.
1 minute, sir. So when we using the P delta, IS 189 the code is silent, not says that we have apply or not. But when we using the concept for the P delta, the effect for the secondary moment, primary moment, this one. So we have need to be consider this one, the formula available for the ASC-716 theta equal to the gravity loads or lateral this one. We have need to be take the parameters, or we have need to be consider, which will become more clear this one. The theta values will become greater than 0.25. The structure will become unstable this one. Or theta max also, which will become less than 0.25. We have need to be considered. So we can calculate manually also, or with the help of Excel sheet also. On the behalf of we have need to be considered, we have required to delta or not. Okay, so these parameters we have need to be considered with the help of our model or apply also. So in that part we have need to identify the elevations or whatever the story forces, center of mass and displacement. Finally, all the values we have need to put this one. The gravity loads we have need to define the pattern. Sorry, one load combinations, all the gravity loads. Okay, these are all the it is all the small how much amount of student also lateral force also clear height also I or CT take the extra code also importance factor or amplification factors. So in that part we have need to be considered what is the I value this one we have need to be considered deflection amplification factor depends upon the framings we have need to be considered importance factor also depends upon the type of framings we have to be taken 1.2 this one we have need to be applied if theta values which will become cross 0.25 this one. Okay, so structure will become unstable. We have need to be redesigned or we have need to take the P delta also. So these parameters we have need to be calculate or apply this one with the help of Excel sheet also available. We have need to be considered. If
Okay.
our results not sufficient,
So
we have need to be
please
defined.
show in the Etab.
Okay, so define part or P delta options. So we have defined the patterns of only this one. It means the structure take the strength, these parameters are. We have defined it only. Okay. So these particular delta we have defined, sir. We have need to be applied the checks or apply in our model.
Okay, fine. Kindly apply that one.
Yes, sir. We have applied this one.
Okay, fine.
Okay. When we performing the analysis, the program performing the analyze again and again.
Okay.
Sorry, it takes some time taken. But when we perform buckling analysis, sir. Okay. Or it's also helpful. Define part or
But first we need to finish that P delta. Na?
Sir, P delta basically we have need to be checked at. We have need to be apply or not.
So
P delta we have defined only.
Okay.
It can include the change in the geometry. It can
fine. I understand. Okay. P delta is just the check that we need to apply or not. Generally, for a low rise structure, it's required. But for the high rise or if you have G+10 story like that. So Karim, I think like from how much story this effect is showing in the structure. Have you any idea about that one? Hello. Sorry, hello, Karim. Sorry, I was disconnected. Karim, my voice is clear?
Now it's okay, sir.
Okay, fine. So, Karim, I was asking about like how much story generally you will prefer to put the P delta, like G+5, 10 like that.
Sir, basically depends upon the code provision, sir. We have need to be applied the P delta or not. One. So this formula we have need to be considered or check our results. Our theta values cross or not. We have need to be apply or not. With the help of we have need to be identify. But IS 1893 code stays silent is one. Not able to define. We have need to be apply or not. It means
So
we are considering.
Okay, I got it. After this P delta, what will be the next?
So basically, it is the geometrical analysis we have need to be considered. Okay. Then moving for the what we call as a buckling part. So load cases, the buckling when we consider this one, we have need to define the cases also this one. Okay. So basically, sir, these are the non-linear analysis. This one, like the buckling, shrinkage part, axial shortening of column. So takes one model, short models. We are explaining this one also, but we are explaining the buckling part also. Modify the showcase or the buckling we have need to be defined, sir. Buckling this one, Or in that part, we have to be taking the patterns, the gravity loads we have to be considered. We are revised later and later also this one. Okay. And also you can see we are including the P delta. So P delta also helpful in the buckling. The scale factor, basically it can give the better results when we using the buckling also. After that, we have, when we interpret our results also, in terms of scale factor will become 1 also when we see our result is 1. So basically, these are the non-linear analysis. It takes time taken to performing the analysis or interpret our results, like the buckling part. Similarly, auto sequence, creep and shrinkage part, this one. Moving for the defined part or auto sequence, as you can see. Okay, we have need to be case will become active or take this one also, step by step. But performing the analysis takes much more time taken also. So creep and shrinkage, auto sequence, it is non-linear parts of this one. Or buckling part, we have also considered this one, so it takes much more time taken also this one. Okay, so moving for the display part or show tables, or when we identify the buckling scale factor, this one basically the results will become once more, sir.
So for the buckling analysis, what you are checking the response.
Yes, sir. Once more, sir. I will open one PPT also, sir.
Hello.
Yes,
Yeah,
sir.
Karim. So the buckling analysis that after doing that one, so how we can check the responses?
Basically, sir, we have made to be check the scale factor also, which will become 1 or not.
Okay, fine. Kindly cover as soon as possible because we have short of time.
Okay, sir. Okay. Okay.
Okay, kindly share the screen and move for the process.
Sir, basically performing the buckling, this one, the buckling factor multiplied with the applied load, this one. We are including the P delta also, this one. So in that part, when we not including the P delta, so scale factors not modify this one. When we performing the P delta, results will become affected this one. So we have defining the patterns like the gravity loads we have need to be considered or revise the scale factor this one also. So after that, we have need to be interpret our results. Basically, the what we call as a scale factor will become 1 or not this one. Yes, sir.
Karim is opening one presentation. That's why it's taking time. Just go.
Sir, basically, we have need to scale factor check that, sir. Basically, the
Okay.
scale factor will become 1. I will check it this one. So when we're defining the pattern, sir, this load cases, the buckling part modify showcase. Okay, so at the starting time we have not include the P delta set in this one. So scale factor will become higher. We have need to be taken the one this. Okay,
fine.
so when we including the P delta, result will become affecting this one. After that, what is the buckling values we have got? We have modified the scale factor also this one. Okay, then we have need to be checking. So basically, we are checked at which options available. We have need to be see the buckling part is one. The scale factor will become one, sir. So these are the non-linear analysis. Basically, we have need to be interpret our results for the buckling analysis. One minute, sir.
After this one, we have some of the left part of the analysis and okay, that if any like any analysis will left, we will cover in our coming session. Okay.
Sir, basically, in this buckling analysis, we are performed. Okay, so we have need to be moving for the display part, sir. This one, show display part or structure. This one, sir. Sorry, buckling factor, sir. This one.
Okay, fine.
And okay. So in that part, it is little bit affected this one. When we see the values, basically,
So how we can fix this value?
basically, sir, when we not using the P delta,
Okay.
so the values will become 140, 130, 5.5, 6.5, some high
Okay.
values.
Okay.
We are include the P delta, the values will become lesser.
Less. Okay.
Okay.
Fine.
Then we have need to be check the what we call as a buckling factors, revise the scale factor, sir.
So how we can see if our value is not satisfactory with buckling analysis, then how we can improve our structure to get the result?
We have need to be modify. You can see,
Okay.
sir, define the load cases, buckling, modify. So you can see we are modify the scale factor. Initially, we are taking the one. We are modify this one.
Okay.
Okay. So these values we have need to be modified in such a our scale factor for the buckling will become one. This one. Okay.
Okay.
So in that
See,
part we have need to be considered.
it's a little bit difficult to understand for all the training, but you can refer to our previous lecture and upcoming lecture also. Okay. Yeah, Karim, please continue. So after this buckling analysis, what will be the next thing that you will cover?
Sir, basically we have moving for non-linear analysis like the creep and shrinkage parts. We have need to be define auto construction sequence. It takes much more time taken, sir, in this
We can see, we
in
can
this
apply.
structure.
Yes, we can apply on the small structure.
Sir,
if possible, yeah. If you have any like short structure, you can open that one. If not, we will cover in our next workshop. Okay.
Sir, basically sequence, creep and shrinkage. After that, the pushover analysis also is also important part, sir.
Okay.
So in that part, we have need to be define the pushover analysis, gravity load case define, along push X also define, see the hinges criteria also. Okay, it is also important part.
So
So
it's
we have required.
basically for the nonlinear analysis. Generally, it's take say if you perform pushover here, it will take like 10 hour, 20 hour like that. So if possible, I will run this analysis and I will put the video. Okay, because analysis video, I will put the video of the analysis. If possible, for the same structure, I will put some of the video because it's very time taking. Okay, it will take like more than 5 hours, 10 hours sometimes. And if your PC are not good configuration, like some training may not have such kind of good configuration PC, so it will difficult for you. So you can try on the 2D frame, like you can make the 2D frame and you can try this type of analysis. Okay, so you will get analysis result in fast, right, Karim?
Right, sir.
So overall, after applying this all the checks, all the things, like how we can conclude that our model is okay. How we can like we have to check for the members, right?
So these are all the analysis criteria. We are deal this one. Type of analysis or interpret our results, sir. Okay.
Okay, fine.
Then once analysis will become complete, then design like the columns, beams, wall, this one. After that, we have need to be create the report also this one. Okay, and DBR also this one.
Okay, just
Then
wait. See, we are not going to finish this model right now because there is like lots of important topic left in this model. Okay, we will cover in the next lecture, next workshop for the what will be the left from here, that we have some of the nonlinear analysis, right? Nonlinear analysis like auto construction sequence, the pushover. This will cover in our next workshop, and the footing and the slab. This
substructure also.
yeah, substructure part, that will be, we will finish in the next workshop. Right now I am sharing you like one report. Okay, based on that, see if you have this report, you can design the structure. Kareem, kindly stop sharing screen. So Kareem has prepared this report. Okay, you can check here. See, this is the report you will able to proceed for the model, like the structure plan. Okay, the codes that you are using, the design methodology, structure plan, project information, software input, load calculation, stability check, and IS code for designs. Okay, so these are some of the, based on this data, you can make whole structure, right? Here you are seeing the structure framing, the material, the frame section, okay, the wall section, the load, that what is the floor thickness, density of the floor. These all are the data input. Okay, the wall loading on the beam. After that, we have the seismic base here. Okay, that you have seen right now. Their specifications, wind load calculations, because the seismic and wind, these are the two major factors. And you have already checked all the things, right? Stability checks, you can refer to here. After that, we will move to the foundation design. Okay, so today we will finish our workshop right here. So if anyone having any question, they can write down email regarding this workshop in detail. Please specify your question in detail, because short-term question or just asking in few words, we are not able to understand. Okay, if you elaborate in better way, you can. Okay, and I will email you that all the video of the workshop and documents on your mail ID. Okay, and kindly email your query and question at TRA. I will write down the email here. Okay. Got it? Kindly email all your doubts, and if you have any questions here, we will try to answer the things. Okay. Yeah, Mr. Murtuja. Definitely, we will in our coming workshop. If you miss the session, they like foundation design and no sir, I will email you all the video that you will need. Kindly message us, okay, on WhatsApp. So I will send the details. Okay, if anybody need any video lecture that are from the previous session, we will also share that one. And any question if you have, kindly share with the on the email. Okay. So once again, I am very thankful to all of you to participate in this workshop. Okay, and this workshop will continue till month of November. Okay, so please be with us, and thank you, Mr. Kareem. Also, like he has done lots of work here. Okay, basically, this all are like combined effort of Mr. Kareem. He is doing lots of research and providing you the data. Okay, so thank you everyone. Again, we will meet on next like upcoming Saturday. Okay, thank you.
thank you, sir. Thank you so much.